All right, 7.1 parabolas. I appreciate you watching this, and hopefully let's get started right now. Uh, Before I get to the columns here of information and have a little information dump here with regards to parabolas, something you should know is that this left column here is when your parabolas are facing up and facing down. Uh, the right column is for facing right and facing left. Now, something to note. Uh, One, facing up, facing down, your squares with your x. Right, left, uh, it's gonna be y squared. All right, when it's facing up and right, this 4p is gonna be positive. When it's left and down, negative. Just like if you remember when we talked about, even in your algebra days, when you did y equals x squared, right? Y equals x squared was a positive, it was facing up. When the leading term was negative, it was facing down. Same story here. Okay, nothing's different. Now, let's talk about what P is, okay? Because it feels like I just threw this P out at you, right? P is, I'm going to use a different color here. Let's use yellow. Yellow is probably a good color for this. Or better yet, let's do black so you can see it. Black. So P is the distance from, and it's really hard drawing this, but it's from this value right here, that little dot inside of your parabola, to your vertex that's right there. Vertex, and once again, my dot right there should be on that graph right there. I just missed it by hair. Uh, but it's that distance. That's P. Okay. That distance, and then that point is what's called your focus. All important things. Now, what your focus does is, and this is pretty neat. And before I get to my focus, I'm going to point out this dotted line right there is your directrix. And what's neat is that also the distance from your directrix to nearest point on your graph. Let me rephrase that. Your distance from your vertex to your directrix is also equal to p. Okay. Now, why is this relevant? Why do we need a focus? Why do we need a directrix? We need these because any point on our graph, which is kind of neat, the distance from any point on our parabola and to any point on your focus, even though this isn't the case in this case, these two lines should be equal. Okay, no matter where it's at on your parabola, the distance from your focus to any point on your parabola to that same point to your directrix will always be equal, which is kind of cool. Now here's all the information how you can find it. I would recommend jotting this down. I didn't talk about axis symmetry. Remember, axis symmetry is that line that cuts your parabola in half. Because remember, parabolas are symmetrical. Uh, so go and jot these down so we can do some practice in solving for these. All right, I have a couple problems here. Let's find the basics. Vertex, focus, axis symmetry, directrix, all the hits. All right, vertex. 4, comma, -3. Beautiful. Focus. How do I find the focus? Well, find the number in front here. Oh, and by the way, we have an x squared here, so that means we're going up. And it's positive. So set 4p equal to 8 anyway. Solve for p. P is equal to 2. What does that mean? We add 2. What did we add 2 to? Well, if it's an x squared problem, we're adding 2 to the y value. So you can get 4, comma, -1. Yeah. Axis symmetry. Since it's a facing up problem, your axis symmetry is always going to be x equals your h value, which is going to be 4. Directrix. Subtract 2 from the y value of your vertex. Since we're subtracting 2, -3 minus 2 is going to be -5. So your directrix will be y equals -5. If it helps you to look at that lovely chart that I showed you before, please do that. So we got 4, -3. Call that 4, -3. And then 2 above is your focus. We have, what else do we have? Directrix 2 below. And it's facing up. There we go. Beautiful. Next, vertex. What do we got? -6, -1. Focus. This is a facing sideways problem, particularly right because it's positive. Also, it's at 4p equal to 2. Unfortunately, we have a fraction. Yuck. P is equal to 1/2 though. That's a fraction we can work with. So we're adding that to the x value. So we're going to get -5.5. Remember, because this is a y-squared problem, so you're adding it to the x instead of the y. Axis symmetry, it's going to be y equals -1. That's where it cuts in half. And then your directrix, go the other way with it, so it's going to be -6.5. X equals -6.5. There we go. All right, next, write each equation in standard form. Identify the focus, vertex, axis symmetry, and directrix. Now, in this case here, we have to use something you might remember in the past, and that is completing the square. Let's subtract 15. And I'm going to factor out a 3 over here. So I'm going to get 3 parentheses y squared plus 2. 2y parentheses equals 12x minus 15. Now, if you remember completing the square, you're going to take the b value divided by 2 and square it. So you're going to add 1. But here's where it gets weird. So even though I added 1, we do to the left side, you must do the right. So if I added 1 over here, you would think you're adding 1 on the other side. But remember, we're actually adding 3, because if we distribute 3 to all the terms, 1 times 3 is 3. So I'm actually adding 3. Not 15, 12. Y plus 1 squared. 3 up front. Divide everything by 3. Y plus 1 squared equals 4x minus 4. Factor out of 4. And that equation should look familiar in your formatting. So what does that get us in terms of vertex? Vertex, 1 comma -1. Focus, your p-value is 1. You set 4p equal to 4, p is equal to 1. What you're adding it to, it's a y-squared problem. So you're adding it to your x. Your directrix. What will your directrix be? It will be 1 less than that. And it'll be x equals. So it'll be x equals 0. And your axis symmetry will be y equals -1. All right, last 2 problems. Write the equation for and graph a parabola with given characteristics. So let's start with the vertex. Y plus 2, and we have x minus 9. Now what gets squared? Well, from the vertex of the focus, the x is changing. So since the x is changing from the vertex of the focus, we know that the y is going to be the 1 squared. Okay, I'll give myself a little space. Now, what's p equal to? Well, remember, it's the distance from the vertex of the focus, and you travel -4 to get from the vertex of the focus. So 4 times -4 gets you -16. So we have our equation there. If we're graphing that, vertex 9, -2, so somewhere over here. Focus is over here. And then we're going to have a pretty wide graph. Okay, and then the other one, focus opens down and contains 5, -10. Since it opens down, we know this is going to be a x squared problem. Not only that, since it's an x squared problem, what stays the same? The x value. So we know it's going to be x plus 3 right there. Now I don't know what k is yet. I don't know p. Right? But we're going to find some of those things out. Now in order to solve for p, I'm going to plug in our x comma y problem. So it's going to be 5 plus 3 squared equals 4p times the quantity, negative 10. Now about this k. Now I'm going to replace k with, so the focus at negative 4, negative 3, negative 4, right? And the distance from your focus to your vertex is negative p. So I'm going to subtract p from negative 4. So now I can just straight up solve for p. 5 plus 3 squared is going to be 64 equals 4p, parenthesis, negative 10 plus 4 plus p. Like terms, you're going to get negative 6 plus p. And then we're going to do a little bit more and distribute. And it's going to get us negative 24p plus 4p squared. I'm going to move the 64 over. Minus 64. I'm running out of space here. I'm going to be able to go to the next page. If I divide everything by 4, much easier to work with. So I'm going to get p minus 8 times p plus 2, giving you solutions of p equal to 8 and negative 2. Now, which one is it? Well, it's got to be negative 2 because it's facing down. So p is equal to negative 2, not 8. So final answer, zoom out so I can see everything. Final answer, x plus 3 squared equals negative 8 times quantity y minus negative 4 minus negative 2, which is negative 2. So plus 2 then. Negative times negative, negative is plus. All right. Appreciate watching. We'll see you later. Bye-bye now.